Okay, dot product. So on matrices, to find the dot product, you just multiply the x parts together, and then you add, and then you multiply the y parts together, just like that. Got a couple of uses. Whoops, I did the wrong number. Okay, you guys get it? 2 times 4 plus 3 times negative 5. That's all you do. 2 times 4 is 8. 3 times negative 5 is negative 15. 8 plus negative 15, negative 7. 3 negative 5.
Oh, I get it. Okay.
Alright, so what would we do on this one?
3 times 7 plus negative 5 times 4.
Yep. 21 minus 20. Let's put it down for now. Okay, now number 3. Find the value of you guys too. Yeah, everybody. 3. Find the value of a if the vectors 4, 6, A3 are parallel. Okay, so for perpendicular vectors, the dot product should equal 0. And for parallel vectors, V and W, let's see. I forgot that one. So anyway, let's do perpendicular first. I'll figure it out in a second. So we're going to do 4 times, or sorry, let me write it down first. 4, 6, A3. Okay, so to make them perpendicular, that's the B part of it. We do 4 times A plus 6 times 3, and you want them to equal 0. And then you solve that for A. Let's you guys try and solve that real quick while I try to remember how to do the parallel part.
6 times 3. Negative 4.5.
Okay, yeah, so negative 18 divided by 4 is negative 9 over 2. Okay, for them to be parallel, vectors are kind of like slopes. So for lines to be parallel or vectors to be parallel, the slopes have to be the same.
So does that mean it's 4?
So it's kind of like we need like 4 over 6. The slope would be more like 6 over 4, but we need like 4 over 6 to equal A over 3. Anyways, how could we solve this?
Well, the answer is 2, but you can multiply that side by 2.
Yeah. 3 times 2 is 6. So what times 2 is 4? It would be 2. What if it was like more complicated than this? How would, yeah, we could cross multiply to solve it. But yeah, in this case, A would equal 2. Alright. See, dot product, not too hard. Okay, on number 5. says that u is negative 2, 3. And they want us to find the dot product of u and u. So if we had two of these, it'd just be negative 2 times negative 2 plus 3 times 3, 4 plus 9. And then for the second part on 5, they want us to do, what did these vertical lines mean? It means the magnitude when it comes to vectors, which means what's the length. So how do I find the length of vector negative u, negative 2, 3 here?
Do distance formula or the Pythagorean theorem?
Yeah, so negative 2 tells me how far it's moving in the x direction, 3 tells me how far it's moving in the y direction. So how do I find the length of the vector? Pythagorean theorem. 2 squared plus 3 squared is
Square root of 13.
and then you take the square root of all that, but then it says we square it. So it is 13. So what are they trying to point out here?
Doesn't move.
If you do the dot product of a vector with itself, that's the same thing as the magnitude of the vector squared. So if you do the dot product and square root it, that would be like the length of the vector, the magnitude of the vector. Basically, this is Pythagorean theorem, right? It's 2 squared plus 3 squared equals 13. Now to find, if I wanted to change it to the magnitude, I'd have to do the square root of that though. Okay, number 7. Okay, this time we're supposed to do u dot v, show that u dot v equals v dot u. So basically to grade these, you have to show your work, show like both sides equal the same thing. So does 5 times 3 equal negative 3 times? Sorry, I said that wrong. 5, 3, 3, negative 7. So if I do the dot product,
It's 5 negative.
Yeah.
negative 3.
But not negative 7.
Okay, so 5 and 3, negative 3 and 7. Okay, that'd be 15 plus negative 21, negative 6. And then if I go the other way, 3 times 5 plus 7 times negative 3. Okay, does that change anything? No. So this one is the dot product of u and v. And this one is v and u. I just switched the order. Did this one first. 3 times 5 plus 7 times negative 3. Get you the same result. Okay, that's the A. So to grade it, I'll be checking that you like wrote this down, but like negative 6 over here. B, we're supposed to show that 2 times u dot v is the same. Okay, now we already did u dot v is negative 6. You know, I'll go ahead and write it all out. 5 times 3 plus negative 3 times 7. So it wants us to do this one first. So that should be, we already did this part, it was negative 6. So if you multiply that all by 2, it should be negative 12. And then they want us to do 2 times u and then do the dot product of that with b. So 2 times 5, 3, dot product 3, 7. So 2 times the first vector would be 10, 6. So if we did the dot product of that, we get 10 times 3 plus 6. Oh, did I miss a negative, didn't I?
No, I think it's negative 3 on the 7.
This one was negative, yeah. Alright, there we go. Okay, so that'd be negative 30 plus 42 is positive 12. Wait, what did I do wrong here? I copy it down right? No,
It's
that was the wrong negative.
3 on the left is negative.
Yeah, that one's negative. Okay.
The right is positive. Wait, what?
So, yeah, when you do the dot product, the negative 3 is on the right, but at the starting vector, it was on the left. So, yeah. There we go. So 10.3 times 3 plus negative 6 times 7. There we go. Now we got it. Okay, so on the first side, the first thing we did was like the left side of the equals, we did the dot product and then multiply by 2. Second time they told us to do 2 times the first vector, which is right here. And then the dot product of that with the second vector. And they come out the same. Alright. Yeah, maybe let's go to 12 today. Okay. These are kind of large. Alright, so on number 9, they want us to show that u dot v plus w. So what should we do first there? U dot v plus w.
Write it out.
Hmm?
Write it out.
V is 1, 3. Right, it's not working. W is negative 1, 2. And we're supposed to show okay, so kind of supposed to show that the distributive property works with dot products. So we got to show that these two things are equal. So what should I do first to find this side?
Add them together and multiply.
Yeah, add them together first. It's not really multiply, it's dot product, but yeah. So v plus w, all these, the book doesn't use this notation, all these are vectors. Okay, and technically these should be like this too.
Do you have to do that for all of them?
No, I'm not gonna worry about it, but anyway, v plus w, how do I add these two vectors together? No, rocket science. How do you add two vectors together?
Add the x's and y's.
Right. So the x values, 1 plus negative 1 is 0, 3 plus 2 is 5. So what would come out of that is 0, 5. And the u vector is negative 2, 5.
So it's 0, 25?
So it's the dot product of those two is negative 2 times 0 plus 5 times 5. Okay, and then for the right side, we just need to show what the two dot products are together. So negative 2, okay, I'm just going to use this. Negative 2 times 1 plus 5 times 3 plus, and then over here I'm going to do the dot product. That'll be my, this thing. And over here we got -2 times -1 plus 5 times 2. And guess what this should equal? So -2 plus 15 is 13. 2 plus 10 is 12. They both add up to 25. So basically that's proving that the distributive property works with dot products. You can distribute out the vectors, number 11. Okay. So there's a formula on the previous page we're gonna have to use for 11 and 12. I'll copy it down. It's angle between two vectors. So we have to do the dot product of u and v over the magnitude of u times the magnitude of v. And then cosine of the angle should equal that. So how would I find this angle? I would do cosine inverse of all that stuff, right? That's how you go backwards to find the angle. Okay, so they kind of tell us the answer, so we just have to show the work. We need to, up top, we're supposed to do the dot product of u and v on number 11. So it'd be 1 times 2 plus 3 times 1 over okay, here's the two vectors. What would the magnitude of this vector be? The 1, 3 vector.
1 squared plus 3 squared.
Right, 1 squared plus 3 squared, square root of that. So it's square root of 10. 2 squared plus, so that's the u magnitude. V magnitude 2 squared plus 1 squared is 5, so it's square root of 5.
So is it 15?
Well, it would be square root of 50, but we don't really need to simplify that because it's not the answer. We just need to do cosine inverse of all that stuff. And guess what should pop out right here?
0.
No, they told us in the question. Show that the angle is 45 degrees. Your calculators might still be set in radians from the last assignment because we did a couple radian problems. I don't know, you just have to check. Anyways, so that's the formula you gotta use. Dot product of u and v over magnitude of u times magnitude of v.